Okay, so the main part that we did like in the previous class was just like on the arithmetic sequence and geometric sequence. But what will be our lesson objective for today is we are going to work on arithmetic series and geometric series. So I had given you guys some lessons to go over. I'm assuming that you have gone through it. So let us just kind of get started with the concept. Just quick recap on the formulas that we had learned about the previous part, which is the nth term of arithmetic. Nth term of arithmetic is un is u1 plus n minus 1d. And geometric sequence is un is u1 r to the power n minus 1. One of the very interesting outcome was here, if you have, let's say, terms in arithmetic sequence, if you got a, b, c in arithmetic sequence, for that matter, d as well, the difference is going to be the same. So you're going to say b minus a equals to c minus b equals to d minus c. So this minus this equals to this minus this equals to this minus this. Maybe this can be used in some of the problem solving. Okay, as far as the geometric sequence is concerned, if you have a, b, c in arithmetic sequence, then b by a should be equals to c by b and so on. So in general, for an arithmetic sequence, you should know that if difference is constant, so let's say difference is generally un plus 1 minus un. And here ratio should be constant, un plus 1 upon un. So these two things are very important part of your sequence verification and understanding. Now, what is really important is that, let's say, I'm going to just take a starter problem here. That, for example, let's say third, fourth, and seventh, third, fourth, and seventh, term of an arithmetic sequence. Term of arithmetic sequence are the first three terms of a geometric sequence. First three terms of geometric sequence. Terms of geometric sequence. It has been given that the first term of arithmetic sequence is a and the difference is d. And using this, you have to get a relation between the a and d. I repeat my question. Third term, fourth term, and seventh term of an arithmetic sequence are first three terms of the geometric sequence, three consecutive terms of the geometric sequence. You have to find out a relation between a and d. This is like one of the questions that has been assessed very frequently. So I'm just going to touch base upon how do you tackle this kind of question as a starter problem. So now first thing is that here you notice is the third term that I can write down can be definitely a plus 2d using this formula. You can see here u1 plus 3 minus 1d, so it will be u1 plus 2d. Since they have specified u1 is a and difference is d, I'll write down a in terms of a and d. Fourth term will be a plus 3d and seventh term will be a plus 6d. Now, since these are consecutive terms of geometric sequence, like for example, a, b, c are consecutive terms, then I can say that b over a equals to c over b. So I can say that, okay, a plus 3d upon a plus 2d equals to a plus 6d upon a plus 3d. So in short, what I'm doing is I'm finding the ratio. Ratio here will be a plus 3d upon a plus 2d because it clearly says they are the first three terms of geometric sequence. So this is the key term that you need to understand. And now if you cross multiply, so this will be a square, a plus 3d the whole square equals to a plus 6d and times a plus 2d here. So if you open the bracket, you get a square plus 6ad plus 9d square equals to a square plus 2ad plus 6ad plus 12d square. Look at for the opportunity for cancelling any particular term. A square and a square get cancelled. And after this, you have got 8ad here, 8ad here and 6ad. So if I strike out, you're left with 2ad here. You got 9d square here and 12d square. If I cancel out, there'll be 3d square left here. So you get 3d square plus 2ad, and this side is 0. So from here, obviously we can take d common. If you take d common and divide other side, or you can just do 3d square equals to minus 2ad. dn, one of the d get cancel, and you get a relation between a and d. So a, you get it as negative 3 by 2d. And this is what we wanted to do. That what's the relation between a and d? What's the relation between a and d? So that's what we got. This is just a starter problem for the class. And this is a very, very important concept as well. So now there is another type of question, which is like your recurrence question. Like recurrence is like using the, what you can say is the formula in terms of not like a arithmetic sequence or geometric sequence. Is like a special type of sequence, you can say, where you specify in terms of the previous given term. Now let us say if I have 2, 4, 6, 8, it seems to be an arithmetic sequence, of course, but let's say if I wanted to write down, let's say the next term. Now, for example, here I'm adding 2 to get this term. I'm adding 2 to get further next term, and so on. And I want to write an explicit relation in the previous term and the next term. So I'm going to specify as un plus 1 is nothing but un plus 2. So you can see that the next term I'm getting by adding 2 to the previous term. So un is the previous term. So previous term, let's say, is 2. And if I add 2 to it, I'll get the next term. So for example, if I wanted to find out, let's say, u3. So I'm going to put u2 if I wanted to find out. So u2 will be, if I take n as 1 here, I get u1 plus 1 equals to u1 plus 2. So u2 that you get is u1 plus 2. And you can see that in the question, it has been given that u1 is nothing but 2. So 2 plus 2 is 4, which is quite evident. Okay, so you can see that this is quite evident. So this is like defining a recurrence formula. Now here you have been given like a structural backbone of the sequence, but lots of times you'll get something like this. They'll give you that. Let's say un plus 1 is 4u1, 4un and plus this 4un plus 3un minus 1. So 3un minus 1. And what you'll be given is like, there'll be some initial condition. Like for example, I'll give you that, okay, u0 is, let's say, 5 and u1 is, let's say, 7. And you have to generate the next 2 terms of the sequence. So what does it mean is I have to get u2 and I have to get u3. So for u2 kids, obviously you can see that I have already n plus 1. So if I replace n with 1 out here, if I replace n with 1, I get u1 plus 1, which is u2, is going to be equals to 4u1, if I replace n with 1, plus 3u0, because 1 minus 1, this is n minus 1. So now from here, you can get the previous value. So 4u1 is nothing but 7 plus 3u0, which is 5. So this is your un plus 1, which is u2. So here it becomes 28 plus 15, which is going to be 43. So you got u2. Similarly, if I wanted to get u3, I'm going to take, I wanted u3 here. So I'm going to take n as 2. So u2 plus 1, which is u3, is going to be 4 n as 2 you have taken. So 4u2 plus 3u1. So 3u1, which is 4u2 is nothing but 43. And 3u1 is nothing but, u1 is your 7. So you can put this. And if you simplify, that gives you the answer for the next step. So lots of time you'll encounter such question either in induction or like along with the basic sequences problem itself. So you guys got to know this particular relation as well. Now coming to the main objective of today's session. The main objective of today's session is the geometric and arithmetic series. geometric and arithmetic series. Majority of the questions are asked around the arithmetic series and the geometric series. So firstly, what is the difference between sequence and series? That's the first question. First key question is, what's the difference between a sequence and a series? So let's say if I've got 2, 4, 6, 8, and so on. This is called sequence. Like if you have a comma in between, then it's called a sequence. Now series is nothing but sum. So 2 plus 4 plus 6 plus 8. This is called as series. Here U1, U2, U3, U4 and all we used to represent the sequence. But for series, we'll be using S1, S2, S3, S4, S5, and so on. Now, when I say S1, what is that? What does it actually mean? Now, S1 simply means sum of first term. So S1 for the sequence is actually U1, which is nothing but 2. The sum of first term is first term itself. S2 means sum of first two terms, which is U1 plus U2. S3 means U1 plus U2 plus U3. S4 means U1, U2, U3, and U4. S5 means U1, U2, and sum of first 5 terms basically. So if I had to look into context of this problem, S1 will be 2, S2 will be 2 plus 4, which is 6, S3 will be 6 plus 6, which is 12, and S4 is 20. So 2 plus 4 plus 6 plus 8, if you look at, is coming as 20. So this is the sum of first 4 terms. This is the sum of first 3 terms. This is the sum of 2 terms. This is the sum of first term. Also, very interesting thing is that if I wanted to find out U4, and if I had assumed that this value S4 and S3, I can do U4 will be S4 minus S3. Common sense is I have sum of first 4 terms, I have sum of first 3 terms, and if I subtract them, I get the 4th term. Similarly, if I have to find out U5, I can write down S5 minus S4. If I have to do S3, U3, I will do S3 minus S2. So sum of first 3 terms minus sum of first 2 terms, you're going to get the 3rd term. So this is the general idea firstly about the series. Now coming back to, let's say, the specific formula for the arithmetic sequence. Now, when you look at the arithmetic sequence formula, what actually arithmetic sequence formula is, there are 2 formulas. Obviously, like, looking at the conjecture. So Sn, whenever you want to add first n terms, there are 2 formulas. Number 1 is n by 2, first term, which is u1, plus last term, which is un. So number of terms you're adding. Here, first term, obviously u1 is first term, and un is the last term. So let us say I wanted to add up the 2 plus 4 plus 6 plus and so on until, let's say, for example, let's say 30. I wanted to add for this particular sequence. So 2 plus 4 plus 6 plus ... 30. It can be very clear that, okay, here there are 15 terms, because you can see that each term is increasing by 2. So there will be 15 terms in order to increase to 30. But in case if you don't know how many terms are there, let's say this is 3000 and it is starting from, let's say, somewhere from maybe 6. And I wanted to find out how many terms, what is the sum of the series? Let's say 6, 8, and so on. And I wanted to find out how many terms are there in this sequence. This series first. So I can equate this last term, because it's one of the term. I can find out at which position is this term sitting at. So let us say if I do 3000 equals to u1, which is 6, plus n minus 1 times difference, which is 2. So this is the new sequence, not the previous one. So from here I get 2994 equals to n minus 1 times 2. And if you divide, let's say, n minus 1 equals to 2994 upon 2. So you get the number of terms basically. So 2994 divided by, let's say 2. So n equals to 2994 upon 2 plus 1. So this is going to be the number of terms in this particular sequence. I mean, in this particular series, which comes out to be 1498. So now I'm going to, let's say, add up. I wanted to finish like with the particular like sum. So sum of all these terms, there are like 1498 terms. So what we'll do is I'll put n as 1498 over 2, and u1 is 6. First term is 6 and last term is 3000. So this is going to be the sum for all these terms in the series. So you don't need to like, add up one on one. You can just plug in this formula and you can get. So first term and last term, these things are to be very important and needs to be noted very carefully. Now there's a second formula that we derive using this, which is n over 2. Instead of u1, instead of un, nth term formula we know for arithmetic sequences, this. So Sn is n by 2, or n by 2, 2u1 plus n minus 1 times difference. So this becomes our brand new formula, which is in case if you don't have the last term, and if they give you the number of terms straight away to add. Now here, like for example, here we had last term, so we could use this formula. But sometimes they'll say, okay, find out some of just like first 1400 terms for the sequence, first 1400 terms. So you can just straight away put the values in this formula. I don't need the last term in that case. So it'll become like, for using the previous data, if I had to do, it'll be 1498 upon 2, 2u1. So u1 is nothing but 6 plus n minus 1, which is 1497 times difference is nothing but 2. So this will be same as this answer. If you actually check it, you will get exactly the same answer. So this is how you add up the series for the arithmetic sequence. So let's do some first practice question on this. So for example, this was a summary of 2. I would recommend that you remember this formula, these two formulas, so that you can be quick in the exams. Now, here are 2 examples that like you can use both the formulas differently. There is no priority that you use one particular formula. But what is recommended is that if you don't know the last term, for example, here, they have just given us few terms of sequence and they have given that, okay, find out the sum of first 50 terms. So you just plug in 50 over 2 and they're using the second formula. So 2 times u1, which is like obviously 4. So 2 times u1 plus n minus 1 times difference. So here you can see that the difference that you have got is 3. N minus 1 means 50 minus 1, which is 49, and you get 3875. But look at the second one is that you don't know the number of terms firstly. Like they have just given the sequence, -6, 1, 8, and 15. So equate the last term, which is 141, to basically the, let's say the nth term formula. So nth term formula is -6 plus n minus 1 times difference. Difference here you can see is +7. So that comes out here. And you get the n value. So you're adding actually 22 terms. So now since we have got the first term and we've got the last term, and we got how many terms we're adding. So you can use the first formula, 22 upon 2. First term is -6 and last term is 141. So you can use the formulas at different occasions. So this is how you do the arithmetic series problems like of the basic level. These are some of the standard level code, and now we will do some problems after this on the higher level. So here, as you can see that there's number of terms has been given to us. So 80 terms, and then there is a difference. You can see that it'll be 80 over 2, 2u1. So u1 is 50 plus 79 times difference. The difference you see is -1.5, -1.5, and obviously you can plug this value on your calculator and you can get the answer. Here you can see that the number of term is not given to us. So you're going to put 101 equals to 5 plus n minus 1 times difference. So difference is nothing but 3. So 101 minus 5 upon 2, which is upon 3, this will be n minus 1. So this is nothing but 96. 96 upon 3, which is 32 equals to n minus 1. And this gives me n is 33. So there are 33 terms in this particular sequence. So 33 upon 2, and you can do first term is 5 and the last term is 1 over 1. So you can just find out the sum using this particular method. So this is how you particularly do this particular question. So here are some more questions that we have to do on the some of the arithmetic sequence, like find the numbers that are multiples of 50 or the multiples of 7, or the number of some of all the integers that are not divisible by 3, or 3-digit numbers which start or end with 4. I'm going to do first 3, A, B, and C, and then I'll leave fourth one to be tried on your own. Then I'm going to pick up and do question number 12. So these 4 questions that will count like some medium difficulty level. So the question is to find out the sum of first 50 multiples of 11. Now, lots of times when these keywords come multiple or factors, you lose it. So please make sure that understand how to create the series based on these key terms. So 11 plus 22 plus 33, these are the multiples of 11. So basically when you're finding out sum of 50 terms, it will be 50 upon 2. First term is 11, 2u1, so 2 times 11 plus 49 times difference, which is also 11. Because if you see difference here, it is 11. It's arithmetic sequence. So this particular like value refers to the answer of the first part. Then they're saying the multiple of 7 between 0 and 1000. So what we got to do is we got to first write down the first few terms and which is the last multiple of 7. So 7, 14, let's say 21, and so on. And we have to find out which is the last multiple, like from behind. So how do I know? How I can't just say okay, 1000 is the multiple of 7. So if you equate 1000 to like nth term formula, if I just show it to you here, if I equate 1000 equals to n 7 plus n minus 1 times difference. Difference is also 7, so it'll become 994 upon 7 equals to n minus 1. And if you try to divide it, it doesn't divide. So which is the last term that is divisible by 7? So it requires some trial and error, like which you can obviously like use your mind and use your logic to get it. So whenever you're finding out which is the last multiple of 7, you have to just see which is the last number that is divisible by 7. So when you do trial and error, I'm pretty sure that 994 is the term that is divisible. So, and 994, you basically solve for n. Now, let's see how many terms are there with 994. So 994, you do minus 7 and upon 7 to get n minus 1. And this seems out to be 141 equals to n minus 1. So n will be 142. So there are 142 multiples of 7 between 0 and 1000. So now when you are adding up the terms, like I can do 142 upon 2. First term is 7 and last term we know is 994. So you can just straight away find this value using your calculator and you'll get the final answer. Now we have to do the C part, which says that find out the integers from 1 to 100 which are not divisible by 3. Now integers which are not divisible by 3 will be always the kind of little difficult option rather than doing which are divisible by 3. So what I'm going to do is I'm going to first find out sum of first 100 integers minus some of the numbers that are multiple of 3, like means divisible by 3. So 3 divisible by 3. So sum of 100 terms like 1 plus 2 plus 3 and so on until 100 is pretty easy task. So it'll be like 100 upon 2. There are 100 terms and then first term is 1 and last term is 100. So you can get the sum easily. But now you have to find out some of the numbers that are divisible by 3. So like which are multiples of 3. So if I find out the numbers that are multiple of 3, 3 plus 33 plus 330, sorry, what I'm doing, 3 plus 6 plus 9 plus 12 and so on until 99. So these are the numbers that are divisible by 3, which is 33 terms you can straight away see. So you can just do minus 33 upon 2. First term is 3 and last term is 99. And if you find this answer, that's the answer for not divisible. It's like sum of all the terms minus some of the numbers that are divisible by 3. So if you subtract them, you're going to get the answer as the sum of the numbers that are basically not divisible by 3.